All right, folks, we're looking at 5.8.2. Okay, so this is, well, first I'm going to review a little bit from last week, but we're looking at how sine and cosine functions and our trig functions are complements. Okay, so complements, what does complementary mean? Complementary angles add up to what? They add up, they have a sum that's to 90 degrees. Okay, it's just summation. So the angles have a sum of 90 degrees. All right. So let's look at what we know. We know this. What does this word mean again? So, ka, to, okay, so katoa. We know that this is talking about our sine, not sin, sine, our cosine, and our tangent functions. And today we're going to basically just look at these two right here, the sine and the cosine. Because what do these tell us? We know that there are three different options here. There's the opposite, there's the hypotenuse, and then there's the adjacent. Remember that trig is just relating sides of a triangle, and we're still working with right triangles. So we know that this is our hypotenuse, and based on where our theta is, if here's my theta, right, that's our angle in question, then this would be the opposite, that'd be the adjacent. Okay, so we learned that last time. So we know that the sine is the opposite over the hypotenuse. It creates a ratio. A ratio is just a fraction. Cosine is adjacent over hypotenuse. Tangent is the opposite over adjacent. Whoops, adjacent. So tangent is going to be kind of out of the loop today. So we're only dealing with the word soka. Just kidding. So SOHCAHTOA is helpful for us to know the angle relationships. Okay, so let's think about this now. And this idea about sine and cosine being complements, it actually, how it plays out is kind of nice. It's kind of easy. It's kind of elegant how it works out. Okay, so let's just look at kind of a scenario where we might see this. All right, first off, right? All right, let's say that this is our theta. Okay, I'm actually for today, I'm gonna label this ABC. Okay, so we know right off the bat, first off, let's say that this is our theta to start. Okay, so angle B is our theta. We know this is the hypotenuse because it's always across from the right angle. We know that across, opposite from the angle, opposite is the opposite. Okay, think of a projector, projects on the other wall. Okay, I put adjacent last because it's the one that's a little harder to see if there is a harder one to see. So we're just gonna first label these sides. Now, let's say we wanted to make our ratios now. And let's go ahead and make it for B. Let's say that the sine of angle B, okay? The sine of angle B, sine is opposite over hypotenuse, so it would be opposite over hypotenuse, okay? Now, here's the thing. Remember that our ratios are based on what angle we're starting with. And I want you to think about this idea. This is how this idea of the complement kind of comes in. Because what do all the angles of a triangle add up to? What do all the angles of a triangle add up to? All these angles have to add up to 180 degrees, okay? So think about this. If this is a 90-degree angle right here, right? We already know that they all add up to 180. So if this is 90, what do these other angles here, angle A and angle B, have to add up to? What is angle A plus angle B, okay? If this side, or this angle here is 90, they all have to add up to 180, then we know that these two angles have to add together to give us 90 degrees, right? A plus B has to be equal to 90 degrees. These two angles have to add up to 90 degrees because this angle C we know is a right angle, and they have to add up to 180 as an entire triangle. So we have 90 plus these two angles have to add up to 90 as well, okay? So within a right triangle, that's kind of like given. We always know in a right triangle that these two, what are called the acute angles, the ones in a right triangle that are less than 90, they have to add up to 90 every single time. So if I had a right triangle here, and we had this as, let's say this is, we'll make it a real obvious one here. So this one's 45, 90. What's this one going to be? 45. It has to be 45, right? So this idea about sine and cosine being complements has to do with that. It has to do with the triangle. All the angles up to 180. Since we're dealing with right angles, right triangles, the other two, these are called the acute angles. Acute, remember, is less than 90. So the other two angles are the acute angles, and they have to add up to 90 degrees. Okay, it's kind of like a little trick that's going to help us. So let's look at how this is going to work, okay? And really understanding that little aspect, the whole, I'm gonna put Toa back up there. Understanding that the two other angles in a triangle add up to 90 degrees is really helpful with this, okay? So let me just pause it real quick and I'll put a practice problem. All right, guys, I want to bring in one of our main terms here. We're looking at cofunctions, okay? So again, this idea about complements between the sine and cosine is related to this idea about cofunctions, okay? So again, I just said that when we have a right triangle, we know that these two angles, these two acute angles have to add up to 90 degrees. And that relationship is what's really important here. It defines how we're gonna look at these cofunctions, okay? So we're gonna label this one B, we'll label this A. When we have cofunctions, okay, we know that if I were to look at the sine of A, okay? Now, the sine of A, let's say that, actually, let me put in a value here. Let's go ahead and let's make some actual values. So let's say this is 30 degrees. Let's say this is 60 degrees. And how do I know that those are 30 and 60? Well, this is 90, so they all have to add to 180. So this is one of our actual identity here, 30, 60, 90 triangles we'll learn about later. But if I'm looking at this, watch. Cofunctions are awesome because the sine of angle A, which is 30 degrees, is going to be equal to the cosine of angle B, which is 60 degrees. All right? So basically, if you look at the two acute angles, you take the sine of one, you take the cosine of the other, they're always going to be equal, okay? So let's see if this works. I'm going to pull up, let's see, new share, pull up a calculator. One second, I have to pull it up. Oh, I love technology. Stop. New share, come on. All right, that was easy. All right, so watch. Let's do this. We have 30, and I'm going to take the sine function of that, and I get 0.5. I'm going to then go and take 60, which was our other angle, and I wrote this down. So, hello. I wrote this down, so we'll see it in a second. Why are you doing this? Why are you doing this? Get out of here. Get out of here. All right. So when I did that, let me get rid of that again. So I did the sine of 30 degrees. That was 0.5. Then I do 60 degrees, and I do the cosine of that, and I get 0.5. Okay, so let's look at that and bring it back to the video. All right, so what I did remember was, since they're cofunctions, these two angles, sine and cosine, are complements. So I know that what I can do is I take the sine of one angle and I take the cosine of the other acute angle, and they're always going to be equal. And let's see if this works. Let's say if I did this the opposite way. So what if I did the sine of 60, right? And let's see if that's equal to the cosine of 30. Now, why did I use 30 and 60? Because those are my two acute angles, okay? So let's go back. Actually, I'm just gonna, it's not very helpful for you to pull that up. So let me just do it here. All right, so let's see, let's put in 60 sine. Make sure you got the syntax for that correct. All right, so we get 0.86. Let's see if that's equal to the cosine of 30. Clear, 30 cosine. 0.86, all right? So now we could see here that the two acute angles, when we're using sine and cosine, if we apply them, right, the sine of one angle, the cosine of the other angle, we're going to get the same ratio. If we take the sine of the opposite angle and the cosine of the opposite angle, we're going to get the same ratio. Let me pause for a second. All right, this brings in what's called the cofunction identities, okay? And this is, I could spell today. All right, so this brings in kind of what we already knew. We already knew that the two acute angles have to add up to 90 degrees, right? And that is really important here. So watch what we're gonna do. We're gonna say the sine of theta is equal to the cosine of 90 degrees minus theta, okay? So let's look at this. Let's see if this makes sense for what we did up here. Let's see, the sine of 30 is equal to the cosine of 90 minus 30. Let's see if this was true. Let's see, the sine of 30 is equal to the cosine. What is 90 minus 30? 60, okay? So we always know that, one, the two acute angles have to add up to 90 degrees. That gives us this insight into these identities. And then when we actually take the sine function of those theta values, we're always going to get the same ratio. It's part of the identity. It's related to the fact that all the angles add up to 180, that the two acute angles have to have a sum of 90 degrees. And this helps us really with this. The opposite is also true. We know that from our other example over here. In this case, we had the same exact thing. We had the sine of theta is equal to the cosine of 90 minus theta, okay? So when I do that, the sine of theta, let's see, sine of 60, that's equal to the cosine of 90 minus 60, that's equal to the cosine of 30. You see? So this identity is very helpful. It helps us know what aspects are reliable, and the identities are going to help us. These are the two identities, okay? It's always going to be basically the sine of one angle is going to be 90 minus theta for the equivalent value for cosine, or the opposite, okay? So let's go ahead and pause for a sec. All right, here we're back. In this case, this is an example problem from the workbook. Let's see. So we're looking at this problem. We're find the sine of 28 degrees if the cosine of 62 degrees is 0.469, okay? So let's go ahead and look at this. First off, let's use one of our identities here. Let's set up our identity. So we know that the sine of theta is equal to the cosine of 90 degrees minus theta. Okay, even if right now you're just trusting that. That's one of our identities. If you didn't catch it, go back, take those notes from the last screen I had here with our two identities, because you're going to use that. And once you start using it, you'll see how easy it is. Watch. The sine of 28 degrees is equal to the cosine of 90 minus 28. You see? So the sine of 28 degrees is equal to the cosine of 62 degrees. All right, so here's the thing. Remember that the identity, right? The identity of sine of theta is equal to cosine of 90 minus theta. Okay, all this is relating to is again, the right triangle. These two acute angles have to add up to 90 degrees. And since the definition of a complementary complements, cofunctions here, because these two have to add up to 90 degrees, and we know that the sine of this angle is equal to the cosine of this angle, then we know that these two are going to be the same. And let's just double check it. You might just be waiting for, when does this get harder? It's a little conceptually tricky, but we can do it. Okay, so let's look. Clear, let's go 20 degrees, and we'll take the sine of that. All right. So the sine of 28 degrees is 0.469. Oh, okay, look what we have. And that is going to be equal to, and we already had that information. All right, so we had to find the sine of 20 degrees given that we knew this amount, okay? And look, the sine of 62 degrees is equal to this. So I can just rewrite it here. I could have done it on the calculator, but I'd get that same exact amount, okay? So here's the deal. All we're doing is proving that these complements exist, that they work, okay? I'm gonna do one more example. Hold tight. All right, folks, we have this table we need to fill out. We're going to use our sine and cosine as complements idea. Okay, so first off, let's remember that we are looking at right triangles. And what do we know about these two acute angles? What do they add up to? They have a sum of what? They have a sum of 90 degrees. They're complementary because this is 90. They all add up to 180. These two have to be 90 degrees. Okay, so we know that those two have to add up to be 90 degrees. So here's the thing. If I'm looking at the two angles, we're already going to assume that these are two acute angles, right? We're not interested or working with the right angle. There's nothing to figure out there. We're using these two angles, acute angles here as our goal. So we have 28. So here's the thing. These are acute angles. We know these two add up to 90. So what does this have to be? This has to be 62 degrees. Now why? Because these are the two acute angles. They're complementary because this is 90. These have to add up to 90. So 28 plus 62 is 90. Okay. Now let's look at this. Why in the world are these two the same? This has to do with our identity. So think about it like this. We know that, let's see, the sine of 28 degrees is going to be equal to the cosine of 90 minus that 28 degrees. Okay. Again, because we know that the sine of this angle is going to be equal to the cosine of this angle. So the sine of 28 is going to be equal to the cosine of 90 minus 28, because that is what that angle measure is going to be. These both add to 90, so if this is 28, this one here is 90 minus 28, okay? So let's see, we already know from this that the sine of this angle, so here's the angle, the sine of the angle is going to be 0.47. And we just simplify this. The cosine of 90 minus 28 is 62 degrees. So we get 0.47 is equal to the cosine of 60 degrees. Look, 62 degrees, we already had it. We knew these are complementary, so I put this as 62. 62 degrees, the cosine of 62 degrees is 0.47, okay? So again, this is just based on the complementary identities, okay? So when I'm looking at this, what is going to go here? Okay, think about that for a sec. Think about that for a sec. And we could do this long way. Maybe you see it right off the bat, you know exactly what goes there. But let's do it long way so you can see another way of doing it. Okay, so watch. The cosine of 28 degrees is going to be equal to the sine of 90 minus 28 degrees. Okay, so the cosine of 28 degrees, I don't know that. I don't have that information. That's what I'm looking for. Let's see what this is. The sine of 90 minus 28 is 62 degrees. So the sine of 62 degrees, 62, sine is 0.883. Now we can go ahead and I know that the cosine of 20 degrees is going to be 0.883 because of our complementary identity. But I can go ahead and work this out on a calculator if I really wanted to. So I'd go over to my calculator, which I shut down apparently. Hello calculator, where are you? There you are. All right, so if I do this and I take the cosine of 28 degrees, 28 cosine, then look what I get. Oh, isn't that beautiful? 0.883. This is, really we only have about 4 more lessons in trig, and I'm starting off slow because I really want this to be something that is solid. We just figured out this was 0.883. So I know for some of you this is going too slow, for others it's going too fast. All right, we have a limited number of lessons we need to get through here, so I'm just taking it a little bit slower. Another announcement is we will not have a final. I'll have some kind of culminating activity, but it won't be a final like a typical final. Also, I am going to the honors project number 3 is going to be optional for extra credit, and I'll have more info on that coming up. All right, I think that actually sets us up to do the homework pretty well. If you need help, shoot me an email and we can meet in Zoom for review any of this material if you like. All right, guys, good job. Go ahead and get on the workbook material, and I'll have a quiz for you later this week. And if you say, well, I just finished the quiz last week. No, that was assigned 2 weeks ago. I just gave you extra time. So I am assigning a quiz every 2 weeks. You'll have a good amount of time to finish it as well. All right, guys, take care. Stay safe, and I'll see you next time.